Thank you. Thanks for the kind intro. So, as the title says, I'm here to talk about scaling performance at Slack scale. Let's just quickly introduce myself again. My name is Aish, and I'm a senior software engineer at Slack. And this is Slack scale. So if you can see, this is a classic hockey stick graph. And if you kind of like look at the numbers from 2018, it's kind of growing like the classic exponential curve. So that should be it, right? It should just be the talk. Like, my name is Aish, I work at Slack. There you see Slack, we can have scaled so much. Shouldn't that just be the talk? And that should just be like the shortest conference talk that you've ever seen. To the ones clapping out there, unfortunately, there's at least 25 minutes of more content, so please bear with me. So guess what this talk is about? So you all might have sort of like come here expecting some kind of deep dives into kind of very technical discussions. You might be thinking this is about databases. Slack does about a bunch of like MySQL, we do Vitess, we do a bunch of database technologies. You all might be wondering that this talk is about databases. To those of us thinking that this is a database talk, I'm sorry, this is not a database talk. I'm wearing a flannel shirt today, and Slack also runs this service called Flannel, about which we've kind of publicly written blog posts about. It's our edge caching system. But this talk is not about Flannel. This is not about edge caching or how edge caching makes Slack run faster on our computers throughout the world. This is also not a talk about Hack or HHVM. So that logo is of the hip-hop virtual machine. Slack runs on HHVM. But this is not an HHVM or a Hack talk. So what's this talk about? Why am I here? This talk is essentially about 3 stories. I'm going to kind of break down slowly the performance problems and in terms of simpler stories that we have seen at Slack, and how we sort of navigated our way, and how we are working on building a culture of performance and having a way in which the knowledge of a performance engineer is actually shared throughout the organization. So let's dive right into the first story. The first story is called the new hires dilemma. So imagine you have relatively started newer at a job, or it could be like you have just switched teams within a larger organization. And you sort of see that there's a bit of a performance issue in one of the libraries, or an API endpoint, or some sort of code that exists there in the component that is owned by your team, and that likely predates your time. How do you go about making that change? How do you sort of step in, particularly as a senior engineer, and say that, hey, this piece of code right here does not seem to be performant? How do you do that? How do you kind of break through those barriers? Do you just like go in on your second day and say, here's a pull request that I wrote that sort of like refactors the most critical part of the product? So that's the big new hires dilemma. Here's a quote from a newer engineer, and this is sort of paraphrased. I'm only familiar with X, which seems to be reasonably performant. How do I go about making performance improvements to it? So let's say you kind of run a distributed system, you see latency numbers that are spiking up. How do you go about making sure that your latency numbers are under control? The team might already have things like monitoring and alerting set up. How do you go about making those changes, particularly if you are newer in the org? How do you work with other teams to kind of make that better? So that brings us to the second story. All threads are busy. It's just a nice picture of a bug, so you might, as you all might have guessed, this is about introducing bugs. Let's say a fine day at work, you walk in, you have your coffee, you go to your desk, you ship some code, and the code that you just shipped calls into a legacy function in a file that was probably modified 5 years ago, that has very little documentation. And once the code goes through all of your stages, you don't really find anything in Canary, like we just heard about canaries in the talk before. They may not always really work. So things go into production, and you see, the latency numbers are spiking up, or the errors are going up. Or maybe the code sits in there for a week, and eventually the latency numbers start to go up. How do you scale that code? How do you scale those libraries about which you don't really knew about? Here's another code. How do I minimize the risk associated with calling the code that may not perform well by today's standards? Because products, software products, are apparently eating the world, but they are also growing slower as they eat the world, just because sometimes they may not really scale well by today's standards. A code that was written 5 years ago may not be really performant given today's volume. So how do we go about tackling this sort of challenges and minimizing risk? The third story is something that would resonate mostly with the senior folks here. It's about scaling yourself. And the first talk by Pat this morning talked about this, about being the multiplier rather than the maker. So this story is going to be resonating with a lot of the folks that sort of felt that they need to be able to multiply themselves. Say you're an engineer with a penchant for finding performance for bottlenecks and fixing them. Say you're like the most seasoned engineer in the company, and you have spent time fighting fires, and you have the necessary knowledge, the experience, the knowledge of the tooling, of the code bases to make performance issues, to fix performance issues. So the challenge here is not that you are not able to fix performance regressions. The challenge here for you is that you cannot fix all of those performance issues by yourself. How do you scale yourself? How do you make sure that all of those new hires who joined the company several years after you did, who wrote code using the libraries that you shipped 5 years ago, know that how to measure performance issues, how to measure performance problems, how to fix them, and how to develop that knowledge and spread it to other teams? Here's another quote by such an engineer. It would be great if it was not just me who discovered performance regressions and fixed them. Human beings, unlike Unix processes, cannot be cloned easily. That's why there's the image of the clone from Star Wars. So how do you go about doing this? So what are the options? So at Slack, we sort of face these situations. And what are the options on the table? So let's look at the most obvious things that could be done or that can be applied. And when I say these are the most obvious things, I don't mean to imply that they don't work. They will definitely work in different cases. So I'm not saying that these don't work. I'm just saying these are the most obvious things that one can do. So one of the most obvious things is you can add performance monitoring. You could use tracing. Now there's like distributed tracing. You could make your systems more observable. You could go and look inside, oh, what's going on wrong? You could figure out the bottlenecks. You could use things like flame graphs and metrics. You could do things like load testing. I remember someone mentioned this morning, do not run load tests from this Wi-Fi. So yes, you could essentially figure out the bottlenecks and scale the resources so that they can handle the load. But that's something that everyone does, or everyone should be doing. What's the alternative? Well, if you think like your company and your product is scaling, another approach that's seen pretty frequently in the industry is having a dedicated performance team. So a dedicated performance team is essentially this team whose sole job is to figure out and fix performance regressions. But what does that mean if you are not an engineer on the performance team? Does that mean that you have a free pass to write code that takes like several hours to complete rather than several seconds? Does that mean you are on the non-performance team? So maybe having a performance team might be a good idea for some time at some places, but for everyone else who's not on the performance team, it's, again, a very difficult thing to do, to not have that knowledge about what goes really on in the performance team. The other one is the classic that I think most of us here as engineers would like to do. Let's rewrite the slower parts of our code base in the latest programming language. Let's rewrite the entire application in Rust, Elixir, or whatever's like my favorite functional programming language. Sure, that might work, but do you think, as engineers, rewriting is a solution that can scale for a long time? The answer, again, depends. If you're a small product, if you just like throwing away your prototype and redoing, probably yes. But if you're a big established product, the answer is probably not. Not for the entire code base. Maybe it's for some parts of it. Another thing that you could probably do is like you could buy everyone a performance book by Brendan Gregg and just say, read this book, come back tomorrow, and then fix all the bugs. That also doesn't really work. So what did we do at Slack? Or what are we doing currently? So I started with 3 stories inspired by how we do performance, or like what are the sort of like the common scenarios that we sort of see. At Slack, we have a variety of like tools, internal and in-house, that sort of measure. We have the metrics and the data. So given all of that, how did we sort of tackle this? This is the crux of the talk. So before we kind of get deeper into it, let's sort of take a step back and see how did we get to the current situation at Slack. So the backstory here is that a few years ago, a group of senior engineers who were interested in fixing one particular performance problem met in a room and started debugging this performance problem for one very particular customer. Unfortunately, I cannot really dive into the details of what customer here, but let's say a very big customer. And they went ahead and they fixed this problem. And in order to collaborate, they created a channel of performance enthusiasts. So what originally started as this like open Slack channel within the company that had most of the senior engineers of the company working on this performance issue started to slowly get attention, which means other engineers who were interested in doing performance started to join the channel. And the channel grew in membership and slowly became the de facto place for people to ask performance questions. Things like, hey, I just looked at this flame graph, and it looks like we're spending a lot of time, let's say, hypothetically, we're waiting for the database connection, or hypothetically, waiting for this particular network call. And slowly, there was the initial seed of a community of performance enthusiasts within the company. But simply creating a channel was not the silver bullet to this problem. What did it start with? It all started with sharing of ideas. One of our principal engineers, while working on a performance issue, started sharing his stories about finding and fixing the problem. These messages in the channel went about with, hey, I looked at this particular problem here that ends up calling like so-and-so function in this particular service, and I found out and I did this. So these were essentially like these mini digestible chunks of knowledge that any engineer could sort of grasp and go in and understand, oh, this is how you sort of measure this problem, this is how you find out this problem, this is how you fix this problem. So all the steps in which from discovery to fixing the problem were there. So if you remember the story, while human beings, unlike Unix processes, cannot be simply created copies of, human beings are really good at sharing information. So sharing information was the first thing that sort of started the entire process of sharing of this knowledge of performance throughout the company. The next part was making sure that the knowledge was simple enough to be shared, and these performance fixes were, again, simple enough to be broken down and shared. Imagine reading a message that sort of changes 20,000 lines of code and says, hey, I made the product 10 times faster. Unless you're really passionate about that piece of code, the chances are you're not going to be reading that pull request, you're not going to be reading that message. So what ended up happening was that there were a series of smaller and smaller changes done incrementally over a period of time by a group of engineers, all sharing knowledge in that one common place. That sort of gave rise to an ecosystem of people who did this thing over and over again and sharing knowledge amongst each other. So the key here was that the fixes that came in were simple enough that other people could also look and be inspired. Recognition to those who worked on these fixes. One key thing that was happening in the middle of all of this knowledge sharing was that the engineers who sort of worked on the fixes, or these smaller incremental fixes, were being recognized by their leaders. So technical leaders within the company recognized those who worked on these performance fixes. That sort of meant that people had that sort of like desire to do this, because because their peers were getting recognition for doing these small fixes. So that sort of led even more people to be encouraged to do these fixes. And this helped create a nice feedback mechanism, which ultimately led to a large number of engineers participating in doing performance fixes, be it on the client side or on the server side. The last one is kind of interesting. Gamification and streaks. How many us here like to maintain streaks? Show of hands, please. Any sort of streak, your GitHub streak or like any sort of streak. I see about like, let's say 25%. So for the rest 75% of us who did not raise our hands, I think streaks are not that important, but for the 25%, at Slack we started not as like a planned way, but there's a mechanism in which we measure if we are meeting a particular SLO or not, and there's a group of people, another channel, another community that sort of sees whether the streak is being met or not. And these are just like a bunch of performance enthusiasts, and having these things in a streak, so how many continuous days have we sort of had the performance improve, maintaining that streak was something that led people to go in and put those fixes. If we sort of did not have that success on a given day, if our streak sort of broke, someone would just go in and put a fix, just because we like to have that streak in place. So back to the stories. So if you remember the first story was about the new hire or the new engineer on the team who wanted to make that performance improvement. How did those cultural changes that I just talked about help that engineer? Remember the first new hire that I sort of referred to? I was the new hire. That was my story. Turns out having someone senior in the org be encouraging and being helpful towards you, and having them sort of broke down the performance requirement of any sort of library or tooling, and having them mentor you and guide you is incredibly valuable. This culture of knowledge sharing went a long way, because when I started, I wanted to make some performance fixes, and I did not know where to start. After coming across the community of people doing performance fixes, I joined them and I started to make fixes. The idea is that if you want to scale your performance team, or if you want everyone to do performance, ensure that anyone can make performance improvement, even if they are a new hire or a new engineer on the team. The second story was about accidentally calling a piece of code that may not really be performant. Of course, and this is assuming like you have monitoring and tooling and all those nice stuff. Training and equipping people with the right tools and knowledge goes a long way. Remember, in the second story, we kind of got all threads to be hanging just because we are calling a legacy piece of code. Turns out once you have enough training and tooling in place, and coupled with the other sort of things that I just talked about, engineers who call these older pieces of code now can go and see what's going on with regards to the code that they just shipped. And that helps them incrementally ship value and provide performance improvements. And the third story is the leadership one, in which, I think Pat mentioned in the first talk, leaders scale themselves by empowering others. So they essentially act as the multiplier. So like I said, as a seasoned engineer who is able to make performance fixes themselves, their next responsibility becomes so that they can empower others within the organization and helping them make those fixes. So with those stories in place and with the learnings of the stories in place, let's just look at the takeaways. So if you were to go back to your work on Monday and sort of summarize what you really learned from this particular talk about Slack, here are some takeaways for you. The first one is that small changes have a compounding effect. So continuous progress is what made us performant. Continuous progress is a thing that can happen over a period of time with a lot of people contributing in smaller and smaller fixes, but over a large period of time. And that ends up having a compounding effect, be it performance or be it culture. The next one is that if everyone contributes, things compound faster. Rather than having one person make big changes at irregular intervals, having everyone who's able to contribute chip in at a regular cadence makes the results get multiplied and compounded over the period of time. And that is it. This is the real end of the talk. Thank you so much.